Hi, this series of lectures will be on coordinate geometry, a very important topic in O levels mathematics. But before we go to coordinate geometry, let's introduce the coordinate system, what they were and how they were introduced. Starting from number line, we remember that the number line was like from negative infinity to positive infinity, and this was 0. This was also known as real line, real numbers. So in this case, like for example, this is 0, so it's 1 2 3. Positive numbers goes on towards right side and negative towards left side. So in number line, suppose we have to represent number 3. So starting from 0, 3 means starting from 0, it's 1 2 and 3. So we represented this point on the number line with this 3. Similarly, if we had to represent negative 5, so starting from 0 towards left, it was -1, -2, -3, -4 and -5. So it was here. This was the best example of one dimension. Like you can either move in positive way, one dimension, or in the negative one dimension. Now, after explaining one dimension, there was a mathematician called Descartes who invented this coordinate system. What he did was like he placed two number lines, one like horizontally, the other one vertically. The first one was known as x-axis or horizontal axis. This was horizontal axis, and the other one was vertical or y-axis. This was known as vertical axis. And just like number line, when we were supposed to represent a number, we needed only one coordinate. In this case, in xy plane, if we need to represent a point, we had to represent it with x and y. Look, any point would be represented by x and y. Suppose this is the point we have to represent. So this was 5 2. Now 5 2 means 5 on x-axis and 2 on y-axis. So this is the point which will be represented by two coordinates, that is 5 that represents x and 2 that represents y. We can see that this is xy plane. This would be called xy plane, or after the name of mathematician, this was known as Cartesian plane. And Cartesian plane and the numbers xy were known as coordinates, Cartesian coordinates. They were known as Cartesian coordinates, and or the xy coordinate that used to be represent numbers on xy plane. The whole thing was known as xy plane because this is x-axis, this is y-axis, and numbers are like 5 2, representing one point on this number on this Cartesian plane. Now we need to know how to calculate, how to find distance between 2 points. So in this case, suppose this be point P, x, y, and the another point is Q, that is x2 and y2. Just to differentiate them, we are giving the name, the first point as P, x1 and y1s, and these are the other point x2 and y2. Now if we see when we talk about a point that this be x1 and y1, by saying x1 we mean the point is x on x-axis, and if we consider this as here, so this is x2. Same is the case with this one, like this is y1 and this is y2. Now if we draw a straight line like this, and same with this, and this be a right angle, we can see that this difference is basically x2 minus x1, which can be said as like x2 minus x1. And same is the case with this one. This is the distance y2 minus y1, which can be y2 minus y1. Now we can clearly see, suppose this point be D. So PDQ is a right angle triangle, and we have to find distance between P and Q. We are looking for this distance. So if PDQ is be a right angle triangle, and we know that on right angle triangle we can easily apply Pythagoras theorem. that states that d the distance is distance square is equal to perpendicular square and base square. So this be x2 minus x1 whole square plus y2 minus y1 whole square. And now if we say taking square root on both sides, taking square root on both sides, we have like this be d square is equal to x2 minus x1 whole square plus it's y2 minus y1 whole square under root. This will be cancelled out, and the distance between 2 points is basically x2 minus x1 whole square plus y2 minus y1 whole square under root. So this is the distance formula. Though in most of the cases you are not asked for derivation of any formula here, but it's really important to know that from which method or how we have derived the particular formula. Okay, now we have a question, like they say calculate the distance between 2 points A, that is 3, 6, and B, 7 and 9. Let's this be the other point. So we have to calculate the distance between A and B with the coordinates 3, 6 and 7, 9. We know that these are the points x1 and y1, and this will be the point x2 and y2. And for formula of distance, it says distance is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. So we're going to put the values in this formula that says distance is equal to, that's x2 7 minus 3 whole square plus y2 that says 9 minus 6 whole square. So if you calculate this is 4 square plus 3 square under root, that gives the values. It's like 16 plus 9 under root, that makes 25, and square root of 25 is 5. So distance is equal to 5 units. Since units are not specified above distance here, so we write it's 5 units. So that's how we calculate distance between 2 points. Okay, now we must know that on x-axis and y-axis, suppose this be the x-axis and this is the y-axis, there must be a general point that will be discussed in different type of questions in exams. So if we are asked to find or locate a general point on x-axis, now remember this thing that on x-axis, suppose we have to take a point C that is always x0, because we know that this is the x coordinate and the y coordinate. Now y on x axis is always 0, and the point, general point on x axis which we'll have to take will always be x and 0. Now same is the case, suppose C is the point that is always x and 0. So same is the case with y axis. When you have to take any general point on y axis, that would be equal to, suppose this be the point, so this is going to be, suppose this is the point D, that is going to be 0 and y, because we know that on y axis the value of x is always 0. So value of x is always 0 on y axis, and this is the coordinate, y coordinate. So on general point on y axis taken would always be 0 and y. You need to keep this thing in mind while solving questions. So now let's see how the questions are coming for like where we can apply a distance formula. First of all, suppose in exam they give you A, B and C are the three points with the coordinates, different coordinates, and you are asked to check if these three coordinates are vertices of an equilateral triangle. Now we know that if a triangle is an equilateral triangle, then all three sides must be same. So what we have to do is, like, we will find distance AB, we'll find distance BC, we'll find distance CA, and we'll find that all three distances are same. If all the three sides are same, then we say that these 3 points are the vertices of an equilateral triangle. Same is the case with isosceles triangle. So if 3 points are given and we are asked to find out if these are the coordinates of an isosceles triangle, then what we need to do that we'll check the distance AB and BC and CA, and you'll find that if two distances are same, then we say that these 3 points are vertices of an isosceles triangle. Suppose you get AB equals to AC, the distance AB is equal to distance AC, then it makes that this is an isosceles triangle. And the last one is for right angle triangle. It's for right angle triangle. We know that if triangle is right angle, it must satisfy Pythagoras theorem. So suppose if this be a right angle triangle, then it's A, B, C. Suppose it's right at 90. Then we'll see that the distance AC, the longest side square, must be equal to sum of squares of other two sides. So if AC square becomes equal to AB square plus BC square, then we say that these 3 vertices are of a right angle triangle. So that's how we apply things on triangles in finding out the nature of the triangle, how the 3 points are related. Here is another question that points A and B, like -2 and 6, and B is the point 9 and 3, and another point C that is on x-axis, are related in such a way that AC is equal to BC. That means distance of A from C and distance of B from C are same. We have to find coordinates of point C. So if we draw a rough diagram that representing x and y axis, now remember that drawing the rough diagrams are not basically required in questions, but it will really help you to solve these things out. So suppose A is the point -2, 6, it must be -2 and 6 somewhere here, and B is the point 9, 3, it must be somewhere here. We have learned that general point on x-axis will always, suppose this be x-axis, general point on x-axis is always x and 0, since y coordinate on x-axis is 0. So C is the point x0, A is point -2 and 6, and B is the point this. It is given that distance AC is equal to BC. So we will simply apply distance formula for representing AC and BC. Both are equal. So if we consider the AC is equal to BC, so apply distance formula in order to find distance between A and C and B and C. So that becomes x minus 2, that will make it plus, minus square, plus 0 minus 6 whole square. And same is the case with B and C, that is 9 minus x whole square plus 3 minus 0 whole square. And now if we take square on both sides, we can easily cancel this square with this bracket, this under root sign, and we are left with like x plus 2 whole square plus minus 6 whole square, that is equal to, it says 9 minus x whole square plus 3 square. Now x plus 2 whole square, this can be basically expanded with the help of algebraic identity, that says a square plus b square plus 2ab. So let's open it, x square plus 4 plus 4x plus, now minus 6 square will give you answer as 36. Same is the case with 9 minus x whole square. Let's open it with a square minus plus b square minus 2ab. So a square plus b square minus 2ab and plus 3 square is 9. Now we can clearly see that x square can be cancelled out with this x square, and the rest is like 4x plus 40, that is equal to 90 minus 18x. And if you bring 18 here, that will be positive 18x plus 4x is equal to 90 minus 40, that is equal to 50. And this is going to be 22x. So x is equal to 50 divided by 22. That can also be written as, in the mixed fractions, 2 whole 6 by 22. So coordinate of x are like 2 whole 6 by 22 and 0. So that's how we apply distance in different cases. In this question, it said that the points A, that with minus 2 and 6, and point B, that's 9 and 3, and the point C on x-axis are related in such a way that the AC, distance of A from C, and distance of B from C are same, they are equal. Find coordinates of point C. So drawing a rough sketch of x and y-axis here, so this will be y-axis, we can clearly see that the point A with minus 2, 6 coordinates is here, and B with 9 and 3 would be somewhere here. And we take C on x-axis, and we know that general point on x-axis is basically x and 0, so 2, 6, so x and 0. If we see the solution, we can see that AC is equal to BC. We apply distance formula to find distance between A and C. We need to formulate things like this, and doing some algebra, we reach to our results. That is x is 2 whole 6 by 22. So that's how we apply the concept of distance formula, the concept of distance on different various questions that come in exams.